Bill Nye's latest findings from Voyager 1 reveal that interstellar space isn't the peaceful void we imagined. Instead, it's a raging storm of plasma waves and chaotic magnetic fields that could destroy any spacecraft venturing beyond our solar system. Did you know that right now, as you're reading this, humanity's most distant explorer is racing through the darkest corners of space at 38,000 miles per hour, discovering dangers that could end our dreams of interstellar travel forever? For 45 years, Voyager 1 has been our cosmic messenger, but its latest discovery has left even the science guy himself calling it terrifying. The Voyager 1 Mission Overview. Did you know that right now, as you're watching this video, there's a 45-year-old piece of human technology hurtling through the darkest corners of space at 38,000 miles per hour? And it just discovered something that's making NASA scientists lose sleep at night? We're talking about Voyager 1, and this story is absolutely mind-blowing. Back in 1977, when disco was king and your parents were probably jamming to Saturday Night Fever, NASA launched what they thought would be a simple 5-year mission to snap some photos of Jupiter and Saturn. But here's where it gets crazy. This little spacecraft, built with technology that makes your calculator look like a supercomputer, decided it wasn't done exploring. 45 years later, it's still out there, still sending us data, and it's now humanity's most distant ambassador in space. We're talking about a machine that's traveled over 14 billion miles from Earth. That's so far that when it sends us a message, it takes over 22 hours just to reach us. Originally designed to study the outer planets and then quietly drift into space, Voyager 1 has become our eyes and ears in regions of the universe that no human technology has ever touched before. And what it's finding out there is changing everything we thought we knew about space itself. Journey beyond the solar system. What if I told you that humanity's greatest achievement isn't landing on the moon, but rather launching a tiny spacecraft that's been traveling for longer than most of us have been alive and just crossed into alien territory? This is where Voyager 1's story transforms from impressive to absolutely legendary. After completing its original mission to Jupiter and Saturn, most people expected this little explorer to just fade into the cosmic background, but Voyager 1 had other plans. For decades it kept pushing forward into the unknown, and then in 2012, something extraordinary happened. It became the first human-made object to punch through the heliopause, the invisible boundary where our sun's protective bubble ends and true interstellar space begins. Think about that for a moment. We literally have a piece of Earth technology swimming in the same cosmic ocean that separates us from other star systems. But here's what makes this even more incredible. Voyager 1 didn't just cross this boundary and stop sending data. Instead, it kept going deeper into this alien environment, continuously transmitting information about a realm that exists beyond everything we call home. Every single day it ventures further into space that no human eyes have ever seen, no human foot has ever touched, and no human mind has ever fully comprehended. It's like having a fearless explorer who never gets tired, never gives up, and never stops reporting back about the wonders and mysteries they encounter in the ultimate frontier. The terrifying discovery. When Bill Nye uses the word terrifying to describe a scientific discovery, you know we're not talking about your average space rocks and cosmic dust. We're talking about something that's keeping the world's smartest scientists awake at night. Here's where everything changes, and why this discovery is sending shockwaves through the scientific community. Voyager 1's recent transmissions have revealed that interstellar space isn't the quiet, empty void we've been imagining for decades. It's actually buzzing with activity that defies everything we thought we knew about the universe. The spacecraft has been detecting what researchers are calling anomalous signals and organized plasma wave patterns that seem to follow specific rules rather than random cosmic chaos. But here's the part that's making everyone nervous. These signals aren't just background noise from distant stars or galaxies. They're persistent, they're structured, and they appear to be responding to Voyager 1's presence in ways that suggest something is actively influencing the space around it. The data shows magnetic field fluctuations and energy signatures that don't match any known natural phenomena, creating patterns that seem almost intentional. When seasoned scientists who've spent their entire careers studying space start using words like unprecedented and unexplainable, you know we're dealing with something that could fundamentally change our understanding of reality itself. This isn't just a new discovery, It's a complete paradigm shift that's forcing us to question whether we've been completely wrong about what exists in the vast emptiness between stars. What the discovery means. You know that moment when you realize everything you learned in school about space might have been completely wrong? And suddenly the universe becomes a much scarier and more mysterious place than anyone ever told you? This is where things get absolutely mind-bending, and honestly, it's the kind of revelation that makes you question everything we thought we understood about reality. The data streaming back from Voyager 1 is painting a picture of interstellar space that's completely different from what every textbook, every documentary, and every scientific model has been telling us for generations. We're not just talking about finding some new particles or discovering a few unexpected magnetic fields. We're looking at evidence that suggests interstellar space is filled with organized structures, complex energy patterns, and activities that operate according to rules we don't even have names for yet. Bill Nye describes it like walking into what you thought was an empty warehouse, only to discover it's actually a bustling factory with machinery and processes you've never seen before. The implications are staggering because if our fundamental assumptions about the space between stars are wrong, then our understanding of how galaxies form, how matter behaves on cosmic scales, and even how the universe itself operates might need to be completely rewritten. Some scientists are whispering about the possibility that these patterns could indicate interactions with dark matter, unknown fundamental forces, or even more exotic phenomena that challenge the very foundations of physics. The terrifying aspect isn't just about encountering the unknown, it's about realizing that we've been living in a universe that's far more complex, active, and mysterious than we ever dared to comprehend. Scientific implications. What happens when a discovery is so groundbreaking that it doesn't just add a new chapter to science textbooks, it forces us to throw out the entire book and start writing from scratch? This is exactly what's happening right now in laboratories and universities around the world, and the ripple effects are absolutely staggering. Voyager 1's findings aren't just challenging a few theories here and there, they're demolishing the entire foundation of how we understand interstellar space and forcing scientists to rebuild their models from the ground up. For over half a century, we've been operating under the assumption that the space between stars was relatively uniform, predictable, and mostly empty. But these new discoveries are revealing a universe that's incredibly dynamic, structured, and filled with phenomena we don't even have proper names for yet. The scientific community is scrambling because this means everything from our understanding of galaxy formation to the behavior of matter and energy on cosmic scales might be fundamentally flawed. Some researchers are now suggesting that these patterns could indicate previously unknown interactions with dark matter, the existence of undiscovered fundamental forces, or even more exotic possibilities that push the boundaries of theoretical physics. The truly terrifying aspect for scientists isn't just encountering something unknown, it's the realization that our most sophisticated models and theories might have been built on incomplete or incorrect assumptions about the very fabric of space itself. This discovery is forcing an entire generation of physicists and astronomers to question everything they thought they knew about the universe. And that kind of paradigm shift only happens once or twice in a century. Voyager 1's instruments and data. Here's something that'll absolutely blow your mind. We're getting revolutionary discoveries about the universe from a spacecraft that's essentially running on the same technology your grandparents used to calculate their taxes in the 1970s. This is where the story becomes almost unbelievable, and it perfectly demonstrates why this discovery is so extraordinary. Voyager 1 is detecting these mind-bending phenomena using instruments that were designed when computers filled entire rooms and had less processing power than the cheapest smartphone you can buy today. We're talking about a plasma wave instrument that's been faithfully recording these mysterious signals for decades, a magnetometer that's picking up organized magnetic field patterns that shouldn't exist according to our theories, and a cosmic ray detector that's showing readings so unusual that scientists initially thought the equipment was malfunctioning. The fact that 1970s technology is capable of making discoveries that our most advanced theoretical models never predicted is like using a telegraph to accidentally intercept alien communications. It shouldn't be possible, yet here we are. What makes this even more remarkable is that these instruments are still functioning flawlessly after 45 years in the harshest environment imaginable, enduring cosmic radiation, extreme temperatures, and the complete isolation of deep space. The data they're transmitting is so precise and consistent that it's forcing scientists to accept that these anomalous readings aren't equipment failures or random glitches. They're genuine observations of phenomena that exist in interstellar space, detected by humanity's most resilient and determined explorer that refuses to give up on expanding our understanding of the universe. Challenges of deep space exploration. Right now, as you're watching this video, there's a team of NASA engineers performing what might be the most stressful job in human history, keeping a dying machine alive that's 14 billion miles away from the nearest repair shop. The logistics of what's happening with Voyager 1 are so mind-boggling that they sound like science fiction, but they're absolutely real and happening every single day. When NASA engineers want to send a simple command to this spacecraft, they have to wait over 22 hours just to find out if it worked. That's nearly 2 full days of nail-biting uncertainty for every single instruction they transmit. Meanwhile, Voyager 1 is slowly dying, losing about 4 watts of power every year as its nuclear power source gradually decays, forcing engineers to make impossible decisions about which systems to shut down to keep the most critical instruments running. The temperature out there is so cold that it would instantly freeze anything we know. The radiation levels would kill a human in seconds, and there's literally nothing around for billions of miles except the vast emptiness of interstellar space. Yet somehow, this incredible machine keeps functioning, keeps exploring, and keeps sending back data that's revolutionizing our understanding of the universe. The fact that we're getting these groundbreaking discoveries from equipment that's essentially held together by 45-year-old engineering and sheer determination is a testament to human ingenuity and the incredible resilience of this little explorer that refuses to give up on its mission to expand the boundaries of human knowledge. Bill Nye's perspective. When someone who's dedicated their entire life to making science accessible to millions of people suddenly starts using words like terrifying and paradigm shift, you know we're dealing with something that goes way beyond your typical scientific breakthrough. This is what makes Bill Nye's reaction to Voyager 1's discovery so compelling and, frankly, a little unsettling. This is a man who spent decades explaining complex scientific concepts with enthusiasm and optimism. Yet when he talks about these findings, there's a genuine sense of awe mixed with concern in his voice that's impossible to ignore. Nye emphasizes that this discovery represents the kind of terrifying that scientists actually love, the terror that comes from realizing how much we still don't know, and how our most fundamental assumptions about the universe might be completely wrong. He's calling this a genuine paradigm shift, comparing it to the moments in history when scientists realized the Earth wasn't the center of the universe, or when quantum mechanics shattered our understanding of reality at the smallest scales. What makes Nye's perspective so valuable is that he's witnessed countless scientific breakthroughs throughout his career, yet he's treating this Voyager 1 discovery as something truly special. A moment that could reshape not just astronomy and physics, but our entire philosophical understanding of our place in the cosmos. He points out that this is exactly how science is supposed to work. We build theories based on the best available evidence, then we test those theories in the real world, and sometimes we discover that reality is far stranger and more complex than we ever dared to imagine. Future of Voyager 1 and space exploration. What if I told you that a single discovery made by a dying spacecraft has just triggered the most ambitious space exploration plans in human history, with missions that could launch within the next decade? The clock is literally ticking for our brave little explorer, and every day that passes brings us closer to the inevitable moment when Voyager 1 will finally go silent forever. Scientists estimate we have maybe 5 to 10 years of power left before it becomes just another piece of metal drifting through the cosmic void. But here's the incredible part. This terrifying discovery has already sparked a revolution in space exploration planning that's moving at lightning speed through NASA, the European Space Agency, and space agencies around the world. Engineers are frantically working on concepts for next-generation interstellar probes that could reach these mysterious regions faster and with far more sophisticated instruments than anything we've ever built before. We're talking about missions that could launch within the next decade, equipped with advanced AI systems, quantum communication technology, and sensors specifically designed to investigate the phenomena that Voyager 1 has uncovered. the European Space Agency is developing breakthrough propulsion systems that could cut travel time to interstellar space from decades to just years, while private companies are investing billions in technologies that could help us better understand what's really happening in the space between stars. In essence, Voyager 1's final act isn't just about making one last discovery, it's about lighting the fuse for humanity's next great leap into the unknown, ensuring that when it finally falls silent, an entire fleet of advanced explorers will be ready to continue its incredible legacy of pushing the boundaries of human knowledge. Why this discovery matters to us. Every single day you wake up, brush your teeth, and go about your normal routine, you're completely unaware that 14 billion miles away, a tiny machine is discovering things that could completely change what it means to be human in this universe. You might be sitting there wondering why any of this should matter to your daily life, but here's the thing that'll absolutely blow your mind. Discoveries like this have a track record of completely revolutionizing human civilization in ways that nobody sees coming until they're already happening. When scientists first started studying electricity, nobody thought it would lead to smartphones, the internet, or the device you're using to watch this video right now. When Einstein developed his theories about space and time, nobody predicted GPS systems, satellite communication, or the technology that makes modern life possible. Voyager 1's terrifying discovery about the complex, active nature of interstellar space could be the key to unlocking technologies we can't even dream of yet. New forms of energy, revolutionary propulsion systems, or communication methods that could connect us with other civilizations across the galaxy. The patterns and phenomena it's detecting might reveal fundamental principles about how the universe operates that could lead to breakthroughs in computing, medicine, material science, or even our understanding of consciousness itself. This isn't just about satisfying scientific curiosity, it's about potentially discovering that we're part of something much bigger, more complex, and more interconnected than we ever imagined. And that realization could fundamentally change how we see ourselves, our planet, and our future as a species exploring the cosmos. So there you have it, Bill Nye's terrifying discovery that's shaking up the scientific world and making us question everything we thought we knew about space. Voyager 1, our little 45-year-old explorer, has stumbled upon something that could change our understanding of the universe forever. The fact that we're still learning, still discovering, still being surprised by what's out there, that's not terrifying, that's absolutely incredible. What do you think about this discovery? Does it excite you or worry you? Drop your thoughts in the comments below because I read every single one and love hearing your perspectives. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries. Until next time, keep looking up with Space Facts. A seismic signal from the moon has just sent shockwaves through the scientific world, and Michio Kaku isn't mincing words. He's calling it a wake-up call for humanity. Kaku warns that this unexpected tremor could mean the moon's core isn't as dormant as we once believed, raising the stakes for both lunar science and life on Earth. Did you know the moon's gravitational pull actually helps stabilize Earth's climate and tides? If the moon is changing, so could our world. Here's a question. Did you know the moon's core might still be active? Seismic signal discovery. A seismic signal on the moon has just thrown the scientific world into a frenzy, and Michio Kaku isn't holding back his concerns. This isn't your average moonquake. This signal was so unexpected and intense that it's forcing scientists to rethink what's happening deep beneath the lunar surface. Kaku, a leading voice in theoretical physics, jumped into the conversation, warning that the moon's core might not be as dormant as we once believed. He explained that for decades, experts assumed the moon was geologically dead, but this seismic activity hints at a mysterious force stirring within. The implications go far beyond curiosity. The moon's core plays a crucial role in stabilizing Earth's tilt and controlling our tides. If something is shifting inside the moon, Kaku warns, it could have ripple effects right here on Earth. Subtle changes in our tides, maybe even our weather. What's even more fascinating is that this seismic event doesn't fit the usual patterns caused by meteor strikes or temperature changes. Thanks to advanced sensors from recent lunar missions, scientists are now picking up signals that were invisible during the Apollo era. Kaku's message is urgent. We're standing at the edge of a new era in lunar science and we need to pay attention. As researchers scramble to decode the moon's signals, one thing is clear: our closest neighbor is keeping secrets. and those secrets might be more important than we ever imagined. Michio Kaku's immediate reaction. When news broke that Michio Kaku had responded to the moon's seismic signal, curiosity skyrocketed across the globe. Kaku's immediate reaction was far from casual. He called the event a wake-up call for scientists everywhere. He emphasized that this wasn't just another blip in lunar data, it could be the first sign of a deeper transformation inside the moon. Kaku's words carried weight, especially as he explained that such seismic activity might point to an awakening of the lunar core, a region long thought to be frozen in time. He urged the scientific community not to underestimate the importance of this signal, warning that ignoring it could mean missing out on a fundamental shift in our understanding of the moon. According to Kaku, the rarity of this event is precisely what makes it so alarming. He drew attention to the fact that our technology has finally reached a point where these subtle signals can be detected and analyzed in real time, making this discovery even more significant. Kaku's passionate call for vigilance resonated with those who understand the interconnectedness of celestial bodies. He made it clear that the moon's fate is tied to Earth's in ways we're only beginning to grasp. As his warning echoes through the halls of science, the world is left to wonder, what else is lurking beneath the surface of our lunar companion, and are we truly prepared for the answers that might emerge? Why the moon's core matters. Beneath the moon's familiar glow, a hidden drama is unfolding that could rewrite everything we thought we knew about our cosmic neighbor. For decades, scientists assumed the moon's core was cold, still, and unchanging, a relic of ancient times. Now, Michio Kaku is sounding the alarm, arguing that the core's activity could be far more dynamic than anyone expected. He highlights how the moon's core, though small compared to Earth's, plays a vital role in shaping the lunar magnetic field and, by extension, the environment that shields the moon from solar radiation. Kaku warns that if the core is indeed waking up, we might see changes in the moon's magnetic properties, which could even affect future lunar missions and technology placed on its surface. The idea that the moon is still evolving deep beneath its crust challenges the long-held belief that it's a geologically dead world. Kaku's insights push us to reconsider the moon's entire history and its ongoing influence on Earth. He suggests that understanding these core processes isn't just an academic exercise, it's essential for predicting how the moon will behave in the future. As seismic signals continue to surface, the scientific community is left with a pressing question. Are we witnessing the rebirth of lunar activity, and what does that mean for humanity's next steps in space exploration? The moon's core, once thought silent, may be trying to tell us a story that's only just beginning to unfold. Potential impacts on Earth. Every so often, a discovery comes along that challenges the very foundation of what we think we know about our place in the universe. Michio Kaku is quick to point out that the moon's core isn't just a scientific curiosity, it's a critical piece of the puzzle that keeps Earth's delicate balance in check. The gravitational pull between the Earth and Moon does more than create tides, it actually helps stabilize our planet's axial tilt, which in turn keeps our seasons predictable and our climate relatively steady. If seismic signals are hinting at changes deep within the Moon, Kaku warns that even subtle shifts could have far-reaching consequences for life on Earth. He explains that a more active lunar core might alter the gravitational relationship between our two worlds, potentially affecting everything from ocean currents to weather patterns. This isn't just a concern for astronomers or geologists, it's a wake-up call for anyone who depends on Earth's natural rhythms, which is, well, all of us. Kaku's message is clear: we can't afford to ignore the moon's signals or assume that its influence ends at the edge of its cratered surface. As scientists race to decode what's really happening beneath the lunar crust, the rest of us are left to wonder how the moon's hidden changes might ripple through our own lives, subtly shaping the world in ways we're only beginning to understand. Historical context. A single seismic signal has upended decades of lunar research, leaving experts scrambling for answers. Michio Kaku draws attention to how past theories about the moon's seismic activity were largely shaped by meteor impacts or the slow cooling of its crust. But this new signal doesn't fit the old script. It arrived with a force and frequency that defies the usual explanations, hinting at processes deep inside the moon that scientists never anticipated. Kaku emphasizes that historically, moonquakes were thought to be rare and easily explained by external events. Now with this unexpected tremor, the scientific community is forced to consider the possibility of an active, evolving core. What's truly captivating is how this event challenges established models of lunar geology. Kaku's warning is that we may have underestimated the complexity of the moon's inner workings all along. The seismic anomaly stands as a stark reminder that even our closest celestial neighbor holds mysteries capable of shaking the foundations of planetary science. As researchers pore over the data, they're left to confront the uncomfortable truth that the moon's story is far from complete. The old assumptions are crumbling, and in their place is a new sense of urgency to understand what's really happening beneath the surface. For anyone fascinated by the unknown, this seismic event is proof that the universe still has plenty of surprises in store. Advanced detection technology. Lunar exploration has entered a new era, thanks to technology that's more sensitive than anything used during the Apollo missions. Michio Kaku highlights how recent advances in seismic detection have pulled back the curtain on the moon's hidden activity, capturing signals that would have gone unnoticed just a decade ago. These new instruments, deployed by international teams and robotic landers, can pick up the faintest tremors from deep within the lunar core. Kaku points out that this leap in technology is a game-changer. For the first time, scientists can monitor the moon's interior in real time, tracking shifts and pulses that reveal its true nature. The seismic signal that sparked Kaku's warning was detected by this new generation of sensors, offering a level of detail that's rewriting the textbooks. It's not just about spotting moonquakes, it's about understanding the moon's ongoing evolution and the forces shaping its future. Kaku stresses that these tools are opening a window into a world that, until now, was shrouded in mystery. The data pouring in is challenging assumptions and pushing scientists to ask bigger, bolder questions about what lies beneath the surface. As the technology continues to improve, Kaku believes we're on the brink of discoveries that could redefine our relationship with the moon, and by extension, our own planet's place in the cosmos. Unanswered questions. A single seismic signal has left scientists with more questions than answers, and Michio Kaku isn't shy about what's at stake. He underscores how little we truly know about the moon's interior despite decades of exploration and countless missions. The recent tremor has exposed a glaring gap in our understanding, forcing experts to reconsider long-held beliefs about lunar geology. Kaku emphasizes that this isn't just an isolated event, it could be the tip of the iceberg, a clue to a pattern of activity that's been hidden for millennia. He challenges the scientific community to confront the unknown head-on, urging deeper investigation and open-minded analysis. Theories are swirling. Could this signal be tied to ancient volcanic processes, or does it hint at something entirely new beneath the crust? Kaku's message is clear. Science thrives on curiosity and the courage to question. He warns against complacency, reminding us that every breakthrough starts with a mystery that refuses to be ignored. As researchers sift through the data, the sense of urgency grows. The moon, once thought to be a silent witness to cosmic history, may be far more dynamic and unpredictable than anyone imagined. Kaku's call to action is resonating across the globe, inspiring a new generation of scientists to dig deeper and listen closer to the stories written in the moon's seismic whispers. Theories and speculation. A seismic mystery on the moon has triggered a wave of speculation among scientists, and Michio Kaku is urging everyone to keep their minds open. Instead of jumping to conclusions, he highlights the need for careful analysis and a willingness to embrace the unknown. Some experts are already floating theories that this signal could be linked to ancient volcanic activity, hinting at a past where the moon was far more alive than we ever imagined. Others suggest it might be the result of the moon's gradual cooling and contraction, processes that could still be shaping its core today. Kaku cautions against settling on easy answers, reminding us that true scientific progress comes from questioning, testing, and sometimes overturning what we think we know. He points out that every seismic anomaly is a chance to uncover new layers of lunar history, clues that could reshape our understanding of how the moon, and even the Earth, evolved. The excitement is palpable as researchers debate the possibilities, knowing that each new discovery brings us closer to solving the riddle of our celestial neighbor. Kaku's call for patience and rigor is a rallying cry for scientists everywhere. Don't just look for what you expect to find, be ready for the unexpected. In this moment of uncertainty, the moon is offering up secrets that could rewrite the story of our solar system. and Kaku wants to make sure we're paying attention to every detail. Call for international collaboration. Global cooperation is suddenly in the spotlight as Michio Kaku calls for a united scientific front in response to the moon's seismic surprise. He's not content with isolated discoveries or fragmented research. Kaku insists that only by pooling resources, data, and expertise can humanity unlock the true meaning behind these mysterious signals. This isn't just a challenge for one nation or a handful of space agencies, it's an invitation for the world to work together on a cosmic puzzle that could affect us all. Kaku envisions international teams sharing seismic data in real time, cross-analyzing findings, and launching joint missions to deploy even more advanced sensors on the lunar surface. He argues that collaboration is the fastest path to breakthroughs, and that the moon's secrets are too important to be kept behind national borders. The urgency in his voice is unmistakable. If the moon's core is changing, the stakes are global, and so must be our response. Kaku's rallying cry is already inspiring new partnerships and conversations among scientists who might otherwise have worked in silos. As the world tunes in to this unfolding lunar mystery, the message is clear. The universe doesn't care about boundaries, and neither should our search for answers. In this new era of space exploration, Kaku's vision of global teamwork could be the key to understanding the moon and safeguarding our future on Earth. What's next for lunar science? A new chapter in lunar science is unfolding, and Michio Kaku believes the next steps could redefine our relationship with the moon forever. He's pushing for more than just analysis. He wants action. Kaku urges the scientific community to accelerate plans for deploying even more advanced sensors and robotic explorers to the lunar surface, arguing that only with a constant stream of real-time data can we truly monitor the moon's evolving core. He envisions a future where lunar bases double as seismic observatories, feeding information directly to researchers on Earth and enabling instant responses to any new tremors or anomalies. This isn't just about satisfying curiosity. Kaku warns that understanding the moon's inner workings could be critical for the safety of future astronauts, the protection of lunar infrastructure, and even the stability of Earth itself. The recent seismic event is a wake-up call, and Kaku's message is clear. The moon is alive with secrets, and it's up to us to listen. As new missions are planned and international collaborations take shape, the excitement is palpable. Each new sensor, rover, and data stream brings us closer to unraveling the mysteries beneath the moon's surface. For Kaku, this is more than science. It's a race to secure our place in the cosmos, armed with knowledge and united by a shared sense of wonder and responsibility. Thanks for joining me on this deep dive into the mysteries of the moon. If you found these insights as fascinating as I did, don't forget to subscribe to Space Facts for more mind-blowing discoveries from across the universe. Hit that bell icon so you never miss an update, and let me know your thoughts or questions in the comments below. Your curiosity keeps this community thriving, so keep those ideas coming. Until next time, stay curious and keep looking up. An object from beyond our sun barreled through the inner solar system on October 19, 2017, moving so fast it couldn't possibly have come from here. Astronomers named it Oumuamua, messenger from afar, and soon realized its brightness was flipping tenfold every 8 hours, hinting at a shape unlike any natural body we've ever seen. Oumuamua initial detection. A cosmic intruder just crashed our solar system's private party, and it came from another star. On October 19, 2017, astronomer Robert Warwick was scanning telescope data at the University of Hawaii when he spotted something that shouldn't exist, a fast-moving object that didn't belong to our neighborhood. The Pan-STARRS 1 telescope had captured humanity's first glimpse of an interstellar visitor, something that had traveled for millions of years through the void between stars just to reach us. What made this discovery so extraordinary wasn't just the object itself but the incredible timing. Scientists estimate that only one interstellar object passes through our solar system every few years, and most are just too small or too fast to detect. Scientists quickly realized this wasn't space junk or a rogue asteroid from our own system. The trajectory was all wrong, the speed was incredible, and the direction it came from pointed to deep space. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar, because it truly was our first confirmed messenger from another star system. The discovery process itself was remarkable. Werik initially thought it might be an error in the data until he tracked the object across multiple images. Within days of discovery, telescopes around the world were frantically tracking this mysterious visitor as it raced through our solar system at 26 kilometers per second. The Minor Planet Center in Cambridge immediately issued alerts to observatories worldwide, triggering an unprecedented international collaboration. The object was already past its closest approach to the Sun and heading back into interstellar space, giving scientists only a brief window to study it before it disappeared forever into the cosmic dark. What they found would challenge everything we thought we knew about space rocks, comets, and the possibility that we might not be alone in the universe. This cosmic messenger was about to rewrite the textbooks and spark debates that continue today. Classification challenges. Scientists love putting things in neat categories, but Oumuamua refused to play by the rules and turned astronomical classification into chaos. Initially classified as Comet C/2017 U1 on October 25, 2017, researchers expected to see the classic signs: a glowing tail, a fuzzy coma of gas and dust as ice sublimated near the Sun. Comets are essentially dirty snowballs that light up beautifully as they approach our star, creating spectacular displays that have inspired humans for millennia. But Oumuamua was having none of it. No tail, no coma, no visible outgassing whatsoever, even though it had passed closer to the Sun than Mercury's orbit. This was like expecting a snowball to melt in a furnace and finding it completely unchanged. Confused astronomers quickly reclassified it as asteroid A/2017 U1, but that didn't feel right either. Traditional asteroids are rocky or metallic chunks left over from planetary formation, and they follow predictable patterns based on billions of years of observation. But Oumuamua's behavior was inconsistent with known asteroid properties. Its rotation rate, brightness variations, and movement patterns all suggested something fundamentally different. By November 2017, the International Astronomical Union faced an unprecedented problem and created an entirely new classification system just for Oumuamua, designating it 1I/2017 U1, the I standing for interstellar. This was the first time in astronomical history that a completely new category had to be invented for a single object, highlighting just how unprepared science was for visitors from other star systems. The classification headache revealed something profound. Our understanding of cosmic objects was based entirely on things that originated in our solar system, shaped by our sun's gravity and radiation over 4.6 billion years. Oumuamua was playing by different rules written in another star system billions of years ago under completely different conditions. Its refusal to fit into existing categories was the first hint that this visitor was unlike anything we'd ever encountered. And scientists began to realize they weren't just looking at a space rock, they were examining an alien artifact from deep space. Trajectory analysis. Tracking Oumuamua's path through space was like following breadcrumbs back to another world, and the story it told was absolutely mind-blowing. Astronomers used precise measurements from observatories worldwide, including the Very Large Telescope in Chile and the Gemini Observatory in Hawaii, to reconstruct its journey with incredible accuracy. What they found was a cosmic wanderer that had been drifting through interstellar space for millions of years before accidentally stumbling into our solar system like a lost traveler finding civilization. Dr. Marco Micheli and his team at the European Space Agency traced its origin to the general direction of the constellation Lyra, specifically toward the star Vega, one of the brightest stars in our night sky. But here's the incredible part. Even if it came directly from Vega, it would have taken 600,000 years to make the journey, meaning this object began its voyage when early humans were just learning to control fire. The trajectory analysis revealed that Oumuamua wasn't bound to any particular star system. It was a true galactic wanderer that had been drifting through the local standard of rest, the average motion of stars in our galactic neighborhood. The object entered our solar system from above the plane where planets orbit, approaching at a steep 122-degree angle that no local object could achieve. This approach angle was like a cosmic signature proving its interstellar origin beyond any doubt. Its hyperbolic trajectory meant it was moving too fast to be captured by the sun's gravity. This was a true flyby mission with no possibility of return. The orbital calculations revealed Oumuamua came within 0.25 astronomical units of the Sun on September 9, 2017, closer than Mercury's orbit, experiencing temperatures of over 300 degrees Celsius before being flung back toward interstellar space by gravitational slingshot effects. By the time astronomers discovered it in October, it was already racing away at 44 kilometers per second relative to the Sun, fast enough to travel from Earth to the Moon in just over 2 hours. The trajectory analysis proved beyond doubt that this was our first confirmed visitor from another star system, a cosmic time capsule that had witnessed the birth and death of distant worlds, survived the radiation of interstellar space, and arrived at our doorstep carrying secrets from the galaxy beyond. Photometry and shape analysis. So, photometry and shape analysis showed that Oumuamua was doing something no space rock should do. It was flashing like a cosmic lighthouse. Photometric observations from multiple telescopes revealed that the object's brightness varied by an extraordinary factor of 10 every 7.3 hours as it tumbled through space. This dramatic brightness change suggested something unprecedented, an object so elongated that it was unlike anything in our solar system. Dr. Karen Meach from the University of Hawaii led the analysis, calculating that Oumuamua was at least 10 times longer than it was wide. Imagine a cosmic cigar, or maybe a football spinning end over end. Some models even suggested it could be more extreme, possibly a 20-to-1 length-to-width ratio. But Dr. Sergei Moshchenko proposed an alternative. What if it wasn't cigar-shaped but pancake-shaped? A flat, disc-like object could also produce the same brightness variations. The tumbling period was unusual too. Most asteroids rotate much faster, but Oumuamua's leisurely spin suggested it might be held together by something other than typical rocky materials. The photometric data painted a picture of an object so bizarre that it challenged our understanding of how planetary formation works. No known process in our solar system creates objects with such extreme dimensions. This wasn't just unusual, it was honestly geometrically impossible, according to everything we knew about how gravity shapes space rocks. Oumuamua was, in a sense, rewriting the rules of cosmic architecture. Acceleration anomaly. And then, there was the acceleration anomaly. Oumuamua just broke physics, and scientists are still trying to figure out how. As telescopes tracked the object's movement away from the Sun, something impossible happened. It started accelerating faster than gravity alone could explain. Dr. Marco Micheli's team at ESA first detected this non-gravitational acceleration in June 2018, analyzing data from the Hubble Space Telescope and ground-based observatories. The acceleration was tiny, only about 0.00005 meters per second squared, but it was real and measurable. For comparison, if you dropped a feather and it fell upward instead of down, that would be less surprising than what Oumuamua was doing. In our solar system, when objects accelerate away from the Sun without gravitational explanation, it's usually because they're comets releasing gas and dust that creates a rocket-like thrust. But Oumuamua showed no signs of such outgassing. No tail, no coma, nothing visible that could explain the extra push. The acceleration was also pointing in exactly the right direction, directly away from the Sun, which made it even more mysterious. Professional astronomers ran the calculations dozens of times, checked their instruments, and consulted with colleagues worldwide. The result was always the same. Oumuamua was being pushed by an invisible force. This single observation transformed a curious interstellar visitor into one of the most puzzling objects ever detected, launching 1,000 scientific theories and capturing the imagination of anyone who wondered if we might not be alone. Spitzer observations. NASA brought out the big guns to solve the Oumuamua mystery, and what they found made everything more confusing. The Spitzer Space Telescope, with its incredibly sensitive infrared detectors, was humanity's best hope for detecting any invisible outgassing that might explain the object's mysterious acceleration. Dr. David Trilling from Northern Arizona University led the observations in November 2017, pointing Spitzer's instruments at Oumuamua as it raced away from the inner solar system. Infrared telescopes can detect heat signatures from sublimating ice and microscopic dust particles that are completely invisible to optical telescopes. If Oumuamua was secretly behaving like a comet, Spitzer would catch it red-handed. The results were published in the Astronomical Journal in 2018, and they were as puzzling as they were definitive. Nothing. Absolutely nothing. Spitzer's upper limits on dust and gas production were so strict that they ruled out traditional cometary activity by orders of magnitude. If Oumuamua was releasing material to create thrust, it was doing so at levels 10,000 times lower than typical comets. This wasn't just unusual, it was physically implausible. The Spitzer observations eliminated the most obvious explanation for the acceleration anomaly and forced scientists to consider more exotic possibilities. Either Oumuamua was made of materials that don't exist in our solar system, or it was being pushed by forces that we don't understand, or, well, it wasn't natural at all. Artificial origin hypothesis. So here's the thing. Harvard astronomer Dr. Avi Loeb dropped a scientific bombshell that made headlines worldwide and honestly divided the astronomy community. Back in October 2018, Loeb and his postdoc Dr. Shmuel Bialy published a paper suggesting that Oumuamua might not be a natural object at all, it could actually be artificial technology created by an alien civilization. Their hypothesis, which was published in the astrophysical journal Letters, proposed that Oumuamua was a light sail, an ultra-thin sheet of material designed to be pushed by radiation pressure from stars. This idea would explain both its unusual shape and the mysterious acceleration, without needing any detectable outgassing. And, light sails are real technology that humans are developing for interstellar missions, so the physics behind it was actually sound. Loeb calculated that an object only millimeters thick, but hundreds of meters wide could behave exactly like Oumuamua, accelerating away from the sun as starlight pushed against its surface. The paper, as you might imagine, sparked fierce debate in the scientific community. Critics argued that invoking alien technology violated Occam's razor, the principle that simpler explanations are usually correct. But Loeb countered that the scientific method requires considering all possibilities, even the uncomfortable ones. His 2021 book, Extraterrestrial, further developed this hypothesis, arguing that scientists' reluctance to consider artificial origins was more about sociology than science. Whether he's right or wrong, Loeb's proposal really forced astronomers to think outside conventional boundaries, and consider that our first interstellar visitor might have been our first contact with alien engineering. Dark comet theory. So scientists found a kind of middle ground between the idea of a normal space rock and the more far-out theory of an alien spacecraft, and it's called the dark comet hypothesis. Dr. Daryl Seligman from the University of Chicago, along with his colleagues, actually proposed back in 2019 that Oumuamua belonged to a previously unknown class of objects that behave a lot like comets, but basically remain invisible to us. These so-called dark comets would have just enough ice to create the non-gravitational acceleration we saw, through a process called sublimation, but at levels so low that our instruments just couldn't pick up the outgassing. The theory suggested that Oumuamua was made of materials that had been altered by billions of years of exposure to cosmic radiation out there in interstellar space. This kind of space weathering could create a dark, carbon-rich crust that would hide any ice underneath and make the object look a lot more like an asteroid than a comet. Computer simulations even showed that tiny amounts of sublimating hydrogen gas, basically invisible to most telescopes, could produce exactly the kind of acceleration that was observed. The dark comet model explained Oumuamua's behavior without needing to invoke exotic physics, or, alien intervention. It also suggested that interstellar space might actually be filled with these mysterious objects, failed comets, planetary fragments, or debris from destroyed worlds that have been wandering between the stars for eons. The hypothesis gained even more credibility when astronomers began finding similar objects right here in our own solar system. Small bodies with mysterious accelerations but no visible outgassing. So, Oumuamua might not be unique after all, maybe it's just the first representative of a hidden population of dark wanderers that populate the galaxy. Dark comet classification. The mystery of Oumuamua got even more interesting when astronomers started spotting similar objects basically hiding in plain sight within our own solar system. In 2023, Dr. Daryl Seligman and his team published some pretty groundbreaking research identifying 7 near-Earth objects that showed the same puzzling behavior: non-gravitational acceleration without any visible outgassing. These objects, now officially classified as dark comets, provided the missing link in understanding Oumuamua's true nature. The research published in the journal Icarus actually revealed 2 distinct populations of dark comets in our solar system. Outer dark comets like 2003 RM and 2010 VK118 follow eccentric orbits similar to traditional comets but show no visible activity. Inner dark comets, like 2007 VA85, orbit closer to the Sun and tend to be smaller, which suggests different formation mechanisms or evolutionary histories. This discovery was honestly revolutionary because it meant dark comets weren't just rare interstellar oddities. They were a previously unrecognized population that had been masquerading as asteroids for decades. The new classification system distinguished them from regular comets and asteroids based on their orbital dynamics and the lack of any detectable coma or tail, despite clear evidence of non-gravitational forces at work. Finding dark comets in our own solar system strongly supported the idea that Oumuamua belonged to this category. It suggested that these kinds of objects might actually be common throughout the galaxy. Invisible wanderers moving between star systems, maybe even carrying ice and organic materials that could seed life on distant worlds. The dark comet classification really transformed Oumuamua from a unique anomaly into the first confirmed member of a whole cosmic population we never even knew existed. Scientific debate. 5 years after Oumuamua's flyby, the scientific community is still, well, fascinatingly divided. And that's actually how science should work. Multiple competing theories keep battling it out in peer-reviewed journals, with each one having some pretty compelling evidence and passionate supporters. The mainstream scientific consensus has gradually shifted toward the dark comet explanation, with researchers like Dr. Jennifer Bergner from the University of California, Berkeley publishing detailed models in 2023, showing how hydrogen outgassing could explain every observed characteristic of Oumuamua. Meanwhile, Dr. Avi Loeb continues to push for the artificial origin hypothesis, launching the Galileo project to search for similar objects and develop new detection methods for potential techno-signatures. Some conservative astronomers prefer explanations involving exotic but natural processes. Maybe Oumuamua was a fragment of a nitrogen iceberg from a Pluto-like world, as Dr. Alan Fitzsimmons proposed back in 2021. The debate has actually produced over 200 scientific papers since 2017, each one adding new pieces to the puzzle. What makes this controversy especially valuable is that it's driving innovation in observational astronomy and interstellar object detection. Projects like the Vera Rubin Observatory, which is set to begin operations in 2024, will discover hundreds of interstellar visitors in the coming decade. The European Space Agency's proposed Comet Interceptor mission could even rendezvous with the next Oumuamua-like object. No matter which theory ends up being correct, Oumuamua has fundamentally changed our perspective on the solar system's place in the galaxy, and reminded us that the universe still holds some pretty profound mysteries waiting to be solved. Alright, that's a wrap on Oumuamua's mind-bending mystery. This interstellar visitor really challenged everything we thought we knew about space objects and honestly left us with more questions than answers. Was it a dark comet, alien technology, or something else entirely? The truth is still out there, just waiting to be discovered. So, what do you think Oumuamua really was? Drop your theories in the comments below. I actually read every single one. And hey, if you're hungry for more cosmic mysteries and space facts that'll totally blow your mind, make sure to hit that subscribe button and ring the bell icon so you never miss our latest discoveries. The universe is full of secrets, and we're just getting started uncovering them together here at Space Facts. Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community. A mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely, possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one Oumuamua and two Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance, it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape. And unlike typical solar system comets that only become active when approaching the sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3Y Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with one Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3Y Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific gold mine. Why are astronomers around the world calling 3I/Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I/Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3. I/Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that one Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3I Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, And the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optics systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3 Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for Rapid Response Interstellar Visitor Encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3 Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3 Atlas continues its ancient journey toward the sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets.